Hello and welcome to this tutorial where I'm going to be looking at mesh scaling in code. I'm going to be turning this magical orb into a pulsing magical orb so that it looks more magical and collectible. I'm going to be doing this using advanced mode in Crayta, and I would approach this tutorial with some kind of idea around scripting. Maybe you've dabbled in some scripting before, or you've been through some of the tutorials that we have on the website and on YouTube that tell you a little bit more about how to script things in Crayta. So it's important that you have some understanding around variables and conditionals and that kind of and functions in order to get the best out of this tutorial. That said, if you want to, you could just follow along and hopefully as I describe what we're doing, things make sense as we go. If you've got any questions, don't hesitate to jump into our Discord, discord.gg/Crayta, and ask questions in the Ask Anything channel, or anything specifically Lua related, probably ask in the Lua help channel. There's always lots of very friendly community members, always willing to jump in and help out. Okay, so without further ado, I have these collectible entities in my game. They're basically the currency entity from something like the adventure blueprint, and I want to make them pulsate in size. So let's go into the editor, into advanced mode, and if I click on this entity, notice that it's got the collectible as the locator there, and the mesh is actually a child of that. The mesh I've added a scale pulsate script to. So I've got an entity add script, new script, and I've just named it scale pulsate. I've added that to the mesh that I want to affect, not necessarily the collectible object. So this is the mesh that I want to make scale up and down. Now, if we look at that script, notice that I am using the client init and client on tick functions here, and that's because this is a visual effect I'm going for. So it doesn't need to work on the server, it needs to run on the client, as it's really only concerned with visuals. If I was doing anything with collisions and mesh scaling, that would probably need to go on the server, but my magical orb, the interaction with the player is handled through this trigger, and the actual magical orb is got collision and off. So it's a visual thing only, and that's why I'm running it on the client. If yours is not just visual and functional, then maybe worth thinking about running it on the server by just using the init and the on tick function. Some of the operations we're going to be doing are a little bit expensive, so worth considering whether you absolutely need them in your game, and maybe consider optimizing them so that they only run when they actually need to. And otherwise, you can just use this as an experiment and to explore the new mesh scaling feature and a little bit of maths as well. So let's get started. So I'm going to create some properties that we're going to use to handle our mesh scaling. The first one is the smallest size. So how small do I want this thing to scale to during a pulse? And it's going to be a vector. Now, some of the meshes will scale using a vector, like this one, for example, which means it can scale in 3 different directions independently. We've got the X value, which is the width. We've got the Y value, which is the depth. And we've got the Z value, which is the height. Some meshes like this beautiful treasure chest here, this will only scale, because it's animated, this will only scale in with 1 value. So this is a uniform scale object. Notice the difference between this using vectors and this one using a single value. So the same principles that we're looking at in this tutorial can be applied to both types of mesh, both those that scale uniformly and those that don't. It's just the ones that scale uniformly will take a number, whereas this one takes a vector. So the smallest size that I want this to be, I'm going to set that to 0.9, 0.9. And let's also make a value, a property for the largest size. And the type is another vector. And I'm going to set that, let's save. the script, then it pops up down the bottom here, and I'm going to set that to 1.1. Let's also add a property for the duration. Scale pulse duration. And this is just going to be a number. You could use the editor seconds attribute, but I'm going to be using milliseconds as well. So I want this to take 1.2 seconds from small to big, and then 1.2 seconds back again. So that's how long I want the pulse to last. If you want to, you can use the the seconds attribute, but I'm not going to be doing that in this tutorial. So we've got a small vector, a large vector to pulsate between, and we've got the amount of time we want to take to do that. So let's look at the most straightforward way of doing this. Would probably be in just the client init function. We get hold of the entity, and then we use the .mesh scale property, and we just set that to the smallest size. So if I save the script now, let's have a look at that in action. With this entity, this orb selected, I'm just going to click the simulate button. And what that's doing now is it's running the client init function and the client on tick function. Client init function runs once at the beginning, client on tick runs every frame. And so this code here has just been executed in the editor, but it gives us an idea of what might happen in the actual game as well. And you can see there's this holographic blue outline of the mesh, and that's where the mesh is normally, and where it is now is where the code has taken it. So if I unsimulate that, you'll see it pop back and returns. So let's now make it pulse between the two sizes. We're going to do this by using a scheduled function, schedule function, and in here we're going to do while true do, so continuously do this. We're going to need a isLarge flag or boolean and start it at false, because starting with our mesh at its smallest size. And in our while loop we'll do if isLarge then, and in here we'll do self get entity dot mesh scale equals self dot properties smallest size, and we'll set isLarge to false. If it's not large, else we can do self get entity dot mesh scale equals self dot properties dot largest size. So set isLarge to true, and then end that if statement, and then wait for the pulse duration before going back to the start again. So this will run continuously, this function. Check if it's large. If it is large, make the mesh small and set isLarge to false. If it isn't large, change the mesh to be large size and set isLarge to true. Wait for the pulse duration and then run that chunk again. And it will continuously do this over and over again. Let's look at it in action. So again, going back to the editor with the mesh selected, I'm going to click the simulate button, and every 1.2 seconds we can see that it's now changing size, and it's kind of pulsing between the large size and the small size. That looks okay. It's a little bit janky, but that's also the most straightforward and simplest way to do this. So maybe this ticks the box for your game, and if you're happy with this effect, then that's cool. If you want to, we're going to have a look at extending this. So how can we make this a bit smoother? We're going to uncheck simulate, and we can do this in a couple of ways. So this way is using just a conditional and a boolean to flick between the two sizes. But we can also use this client on tick to do things smoothly, either with linear interpolation, which is something we can look at, or using a sine wave, which is even better. So to start with, let's look at this from a linear interpolation way. So I'm not going to need this schedule anymore because I'm going to be using client on tick. A couple of things I'm going to need to set up. I'm going to need to make this local variable a class level variable. So self.isLarge rather than local is large, which means I can use this variable in this function as well. I'll also need self.elapsed, and let's set that to 0, and that's going to keep a track on our time. So when it comes to the client on tick, let's increase that of elapsed value. Self.elapsed equals self.elapsed plus delta time, which is the amount of time that's passed since the last time that this function was run. And so that's that bit. And then what we need to do is linearly interpolate from one size to the other. So we're starting at small. So let's get hold of a new size. Let's create a new size vector. And this is going to be vector.lerp, which stands for linear interpolation. And we can put in two different vectors here. The one we're going from, self.properties.smallest size. The one we're going to, self.largest size. And how far, largest size. And how far along that journey are we as a percent from 0 to 1? So to work out that percent, or alpha as it's called, we're going to create a new variable above that line of code, local alpha, and that's just going to be self.elapsed over self.properties.pulse duration. And we can then plug that in as the last value in the function. So this function will return a vector between the smallest size vector and the largest size vector. And what it returns is, if alpha is 0, it returns the smallest size. If alpha is 1, it returns the largest size. And if alpha is 0.5, it will return the exact halfway point between the smallest size and the largest size. If alpha was 0.25, it would return 1/4 the distance between smallest size and largest size. And so you can get a fraction between the two different vectors according to this percentage, and it works that out in a smooth way. So this is a really good way to smooth the transition between two vectors, kind of like using a percent. Now it's not quite finished, because if we continue to add delta time to this elapsed, it will go past the pulse duration and it will keep on going. So let's have a look at what that looks like if I just simulate it. I'm not actually updating the size of the mesh. So self get entity dot mesh scale equals new size. Just finish that line off, and then let's simulate it, and we'll see that it's smoothly growing, but it doesn't stop. So if I left this going, this magical orb would devour us all. So we need to make sure that it's still bouncing between the small size and the large size. And so to do that, we're going to be using this isLarge property here. So we need to keep hold of that alpha value. So self.elapsed is increasing constantly. But what we want to do is check if self.elapsed is greater than self.properties.pulse duration, then we want to set self.elapsed to 0, and we will reverse self.isLarge to be the opposite. So we can flick that between true and false by doing self.isLarge equals not self.isLarge. So not false is true and not true is false. Then we'll work out our alpha, which will be the same either way. Our new size, however, we'll establish that as a vector first here, and then we'll run a condition if self.isLarge, then new size equals that. Yeah. And then else, and we'll just copy and paste this code. So we're still lerping between two sizes, but if the mesh is large, we need to swap these around. So if it's large, we go from largest size to smallest size. If it's not large, we go from smallest size to largest size. And so that now should give us that pulsing motion. Let's simulate it and have a look. So small to large to small to large, and it's taking 1.2 seconds in either direction. So that's how we can make something pulse using linear interpolation. There's one more way I wanted to look at before the end of this tutorial, and that's by using math.sine. Now, if we look carefully at this pulsing orb, we can see that the edges of the scaling, both up and down, the edge of that motion is instant. So it goes large, small, and that's because it's flicking that Boolean still. So whilst it's gradually increasing and decreasing in size, the switch between the two is still quite janky. And we can get rid of that. We can get rid of that jankiness by using maths instead of Booleans and linear interpolation. So a lot of this can remain, but I'm going to remove this bit here. We still need this elapsed to be increasing, but we don't need to flick that Boolean anymore. What we will need is delta size, which is the difference in size between the largest size and the smallest size. Self.properties.smallest size. And so because we're going to be moving within that delta size there. So I'm creating a new vector called delta size, which is the difference between the largest size and the smallest size. So it's a vector as well. And we will be using math.sine to change that. So local new size equals, and this should be vector new math.sin, and we will be getting hold of self.elapsed. Now this should be actually, let's return this alpha, self.elapsed over self.properties.pulse duration. So that will continue to go up, but because math.sine is a continuous curve, it goes both up and down. We don't need to flip it using Booleans anymore because it flips mathematically. We're not going to use elapsed here, we're going to use alpha here. And so that's our frequency, is self.elapsed over pulse duration. Now let's multiply that by our amplitude, which is self.delta size.x. And we need to do the same for y and z. So I'm just going to copy this line of code, .y and .z, close that bracket there. So we're creating a new vector, which is taking the, which is using math.sine to establish the size of each dimension, and it's using the frequency generated from self.elapsed over self.property pulse duration and the amplitude of the size in each dimension. That's the delta size in each dimension. So now if that set to that, it's not quite finished because remember delta size is only the difference between the largest size and the smallest size. So it's just the difference. We need to also at this point plus add self.properties.smallest size plus new size. So it's a new vector that's got a minimum of smallest size, which is 0.9, plus the sine of the difference between the largest size and the smallest size, according to the pulse duration. So let's have a look at what that looks like. So if I simulate that, we can see now that at the very edges of that motion, it's a lot smoother. Yeah. So it's a much smoother pulsing, and we can speed it up a little bit by decreasing this pulse duration. We can even change the maximum size it goes to. So it goes to size of 1. And that's looking pretty nice. Let's have a look at that in action. If I add the script, if I change this script so that we've got those values as our default. Change those values. So you can do that. And then let's add this script. Called scale pulse. 1.1. 1. That's our default. So I can now go about and because these are using templates, I can just do it once in the template. Add script. Scale pulsate. Do that for the ones too. So large ones. Collectable. Orb itself. Add script. Scale pulsate. Those values all right. Let's now test our game. And so all of my collectibles should be pulsing. Yeah, there we go. Pulsing collectibles. Hooray! So that's how to use the mesh scaling API to scale our meshes to make them pulse in and out, and a few different ways of doing that, starting with the simplest, which was just using a boolean to flick between large size and small size, through vector linear interpolation, all the way to math.sine in order to very smoothly change the size of our meshes. I hope this has been a useful and interesting tutorial, jam-packed with a few different ways of doing the same thing. And I look forward to your pulsating meshes in Crayta.